correct.
Oh, well, I guess we'll go ahead and move on. We'll try again later, okay?
I don't think so.
Hi, everybody. Welcome to day 12, our 12th lab activity.
5 golden rings.
In this week's walkthrough, we'll be looking at the behavior of waves and using their movement on a string to give us better insight into wave motion. In particular, we'll be looking at destructive interference, constructive interference, and we're looking at the harmonics of simple waves. But before we get into all that, let's take a look at this week's PreLab activity. In today's PreLab, you're going to explore the harmonics within your own voice or some instrument that creates sound that you can play and take a signal from at the same time. The app that I have suggested using is called Spectroid. It is available for Android devices. It's not available apparently for iOS devices. So if you do have an iOS device, there is a free one online that I will send out, or you'll see right here in the screen in just a moment. But you can look for that one as well, and it does the basic same idea. Here's what you want to do. You see this red background there, that's the max settings, and this is also available in the iOS generator, the iOS spectrum generator. But you see, as you speak, there are different tones that come out of your voice. So we'll reset this, and then we're going to make a noise of a steady tone. And I will use the gentle voice of my 8-year-old. And as you can see from her voice, even though it sounded like it was one tone, it's actually the main tone and then several harmonics, which you can move your cursor over to and identify. So this is about 475 hertz. Here is about, and you have to play with it a little bit, you may have to zoom in, 926 hertz. This peak is, you can zoom in. You can zoom in and out as you need to get a better feel for a particular, to this 938 over here, 1406. You'll record those down, mark them on your PreLab sheet, mark them out, and then see if they're integer multiples of the lowest frequency, or if there is a lowest frequency that they're integer multiples of. You'll take those calculations, put those on your PreLab, and submit. And this will be the last PreLab you have to do for this semester. The main equipment that you'll be needing for this lab activity is going to be this mechanical vibration generator by PASCO Scientific. And what you use is connected by a red wire and white wire to these two ports, connect them into the 850 interface at the signal generator option, and then we'll see in the PASCO setup here shortly what settings you need to take in order to make in order to get this operational and start vibrating the string. You'll have masses in the usual way from your hanging mass. There's not much else beyond this except for the string. The string is currently going to be fixed to your pole, but you can take it off and take it over to the sensitive scale and get the very accurate and good precise mass of the string. It does matter in this case, even though it's very light, it is important to know what the mass of the string is in order to do your calculations. Once your equipment is put together in place, you'll notice the setup. You have your vertical rod over here at one end, string tied to it, looped around it, fed through your frequency generator. It'll be fed over a pulley wheel and go down to a hanging weight. We'll add masses, but before we do, we're going to push play. It's already been set up, so we're going to push on. And you can see that a wave has begun on the table. So now she's going to add some weights and see what happens. The hanger itself is 5 also.
So yeah, we have 30 grams.
30 grams. So in that ballpark, you'll be able to get to your 4 segments. And you'll have to play with some masses in order to get it down to your 5 segments. Stop making that noise. So we have 30 grams on there, which means that around 30 grams we can get to 4 segments, which is a good place to be. You may want to play with that mass just a little bit in order to get your in order to get the best precision for your wave speed calculations. In order to go down to your 5 segments for the final section, you just remove some of those masses and get it down to about 5. You may have to adjust the length of your string and hold it fixed at that point, so I'm not going to suggest that. Now that you're familiar with the setup and the operation, let's go ahead and get into the PASCO so we can see how to set the mechanical vibrator. Okay, so once you've launched Capstone, you simply go over to the hardware setup as we usually do, open that up, you'll turn to the page, you'll see on the right hand side of the screen, you'll see the little yellow dot for the signal generators. You click on the output frequency sensor, and then you'll notice that the signal generator has shown up on your tools palette. So you close your hardware setup, you go down and you click on signal generator, and it's in the signal generator that you make sure that you have all the settings according to the 4 or 5 settings that are listed in your lab manual. That's 60 hertz frequency for sine type waveform. You want sweep type off. You want to make sure that your phase shift is 0. Your amplitude is 5 volts. And then this is also the panel that you use where you click on and you click off. And that's all there is to using the Capstone experiment. Any data analysis that you're going to do will be done in Excel, and you can just use Excel to create either a force versus velocity plot, which will be quadratic, or a force versus velocity squared plot, which will be linear. And you should discuss with your TA which one is a superior fit and why. Well, that does it for this week's walkthrough. I'd like to thank Jennifer for joining us and helping us out today. Keep in mind that even though this material didn't really show up in lecture for most of you, it will have a significant influence on your understanding of the materials that will be covered in Physics 2 if we see you there. So hopefully we'll see you in Physics 2. But before then, we'll see you in the lab. See you all later.
Bye.
Because now we're not going to be doing that. Okay, so I'll be able to log in.
Peekaboo. Hello, I'm right here.
Alright.
Oh no.
So we're going to have quite a few bloopers there, buddy.
What's a blooper?
That's where something doesn't go quite according to plan. Actually, I wonder if I can do the PASCO setup right now. Good?
Yeah.
Alright, where's my list? We gotta check it twice. Gotta find out
Who's naughty and nice? Santa Claus is coming to town. Terrible.
Blah, blah.
If you're awake, he knows if
Musical
you've
interlude,
been
folks.
bad or good, so be good for goodness sake.
And use as an example for waves that you can't laugh through a broken take. Do professional. Let's be professional. Professional. But you can't make a smile for it. Shucks, I forgot what I was going to say.
Oh no. I guess we gotta cut the video now.
And make sure that if you have any questions or want to understand further about the waves that we're exploring in this lab, make sure you consult your textbook, talk to your instructor, talk to me, talk to everybody. And keep in mind that the stuff that we're going over in this lab, while not seen this semester, will have great impact on for those of you who will. Keep in mind that the material that's going on in this lab, while maybe not covered in this week's lab, while not covered in this year's and this semester's. Is there a problem?
It's just the fact that you keep messing up over and over again.
Yep. Whoop.
Oh my gosh. That is so funny.
Did you just shrug?
Yes. Okay, I'm good.
Well, that concludes this week's PreLab. Well, this concludes. Okay, well, that does it for this week's walkthrough. We got a composure failure here.
On both of us.
You want to improv or you want to plan it?
Bye.
Bye. Bye. See you later.
See you